Okay, lesson 13.2 is theoretical probability of compound events. And again, compound events, just like in experimental probability, is more than one event. So we're going to find the probability using a table. Jacob rolls 2 fair number cubes. Find the probability that the sum of the numbers he rolls is 8. So in this table, we're going to use this to come up with our outcomes. We did this in our little lab activity we did with the number game. So we're going to be adding these numbers together to figure out what their sum would be. Okay, so in my chart, I'm just going to add like 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5, 1 plus 5 is 6, and 1 plus 6 is 7. And you continue to fill out your chart. 2 plus 1 is 3, 4, 5, 6, 7, and 8. Go ahead and fill out this chart. 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, and 7, 8, 9, 10, 11, and 12. Okay, so that is our sample space. That's all the outcomes you could have. So if I were to roll 2 fair number cubes, I have 36 different outcomes. Okay, and then those outcomes are listed in this table. So we want one that has a sum of 8. So if we look at here, we have 1, 2, 3, 4, 5 times a sum of 8 was rolled out of a total of 36 outcomes. So that is the theoretical probability of rolling 2 number cubes and getting a sum of 8. Okay, the next example says, give an example of an event that is more likely than rolling the sum of 8. So which one occurs more likely than 8? Well, if we look here, we have a nice little pattern going on, right? So right down here, we have all these 7s. Okay, 7 occurred 1, 2, 3, 4, 5, 6 times. So one that would be more likely than rolling a sum of 8 would be rolling a sum of 7. And the next one says, give an example of an event that is less likely than rolling an 8. So 8 occurred 1, 2, 3, 4, 5 times. The only other number that occurred 5 times was 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, right? So any of the other ones would be less likely. So I'm going to say rolling a sum of, I'm going to just say 9. Okay? I could have said 9, 10, 11, 12. Any of those would be less likely than 8. Okay? The next one says to find probability using a tree diagram. And a tree diagram is another way to find sample space. Okay, so again, we have a deli that prepares sandwiches with one type of bread. So we could have white or wheat bread. Okay, so we're looking at bread type. One type of meat, and the meat choices are ham, turkey, or chicken. One type of cheese, and we have cheddar, Swiss, and then each combination is equally likely. Find the probability of choosing a sandwich at random and getting turkey and Swiss on wheat bread. So we have our bread choices. I'm going to make this a little bit bigger. So we have bread here. We have a meat choice and our cheese. So again, our bread was white and wheat. Okay, and then from that bread choice, we have 3 choices of meat. We could have ham, we could have turkey, or we could have chicken. Same thing from the wheat bread. We could have a ham sandwich, turkey, or chicken. And this tree diagram is just a nice way to show our entire sample space. Every event that can occur. Whoops, I forgot my E on cheese. Now from each type of meat, we have two choices of cheese. We could have cheddar or Swiss. And that's going to come from every meat choice. Cheddar or Swiss, and cheddar or Swiss. Same thing happens down here. Maybe just a little bit bigger so again, from our ham, our turkey, and our chicken, we have cheddar and Swiss, cheddar and Swiss, and cheddar and Swiss. So now if we follow these along, we could even have our sample space over here if we wanted to rewrite it all, where I could write out white ham cheddar, white ham Swiss, white turkey cheddar, white turkey Swiss. So we could follow all these out and write them, but we don't really need to because we can see what each choice is. So it asks us the probability of getting, let's start with this one. Turkey, Swiss, and wheat was the first question, right? So of those, with wheat bread, turkey, and Swiss, there's only one, right? Wheat, turkey, Swiss. There's one out of how many choices? If we count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different sandwiches. So the turkey Swiss is going to be 1 out of 12. Now ham is going to be ham with cheddar and Swiss, and down here ham with cheddar and Swiss. So we could have wheat, ham, cheddar, wheat, ham, Swiss. We could have white ham, cheddar, and white ham, Swiss. So there's actually 4 sandwiches that have ham. So 4 out of 12, or if we simplify that, we get 1/3. What is the probability of sandwich with Swiss cheese? Well, we could have white bread, right? With Swiss cheese, we have 1, 2, 3 of them. And then we could do the wheat bread, and we have 1, 2, 3 of those with Swiss cheese. So that would be 6 out of 12, or 1/2. Okay, and then the last way you can find probability is by making a list. So you could use your table, you could use your tree diagram, or you could just write it as a list. So let's just say we were flipping 3 coins. Okay, so I could get heads, right, with my first one, heads with my second one, heads with my third one. Then on my next one, I could get heads, heads, tails. I could get heads, tails, heads. I could get heads, tails, tails, right? Okay, now that was starting with H. Now if I start with my tails, I could get tails, tails, tails. I could get tails, heads, heads. I could get tails, heads, tails. And the last one would be tails, tails, heads. Okay, so that's just a list of the outcomes we could have. So I listed all my possible outcomes of flipping 3 coins. Okay, so that'd be a way of just putting a list. And then a way you could tell, I want to go over this, it's called the fundamental counting principle, how many outcomes there are. I know that there are 8 outcomes on this one. And the reason I know there are 8 outcomes is because you can multiply the number of ways each event occurs to get your total. So if I flip 1 coin, right, I have 2 outcomes. And then I just keep multiplying them. My second coin also has 2 outcomes. And my third coin has 2 outcomes. So I know I'm going to have a total of 8. And that's called the fundamental counting principle. We could go back up to all of these. So we do the number of ways times number of ways times number of ways. So we had 2 types of bread, 3 types of meat, 2 types of cheese, tells me that I'm going to have 12 outcomes when I get done. So you might want to double check using the fundamental counting principle, which I believe we went over last year, to help you figure out how many outcomes you should have. If we go back up to the first one, we rolled 2 number cubes. So the first one, there are 6. The second one, there are 6 outcomes. So you should have a total of 36. So you can always double check your outcomes by using the fundamental counting principle. Multiplying the number of outcomes times number of outcomes times number of outcomes. How many ever events you had? We had 2 here, 2 number cubes, right? Our first one, our second one. Here we had 3 different events because we had bread, meat, and cheese, right? And down here we had 3 coins. So that'll allow you to say the number of outcomes, not what they are, but how many you should have. Let's go ahead and do guided practice. Okay, your guided practice, you should be on page 408. It says to complete the table to find the sample space for rolling a particular product of 2 number cubes. So now we're going to fill out the table for products. We're going to multiply those. So 1 times 1 is 1. 1 times 2 is 2. 3, 4, 5, 6. Now we're going to count by 2s. 2, 4, 6, 8, 10, 12. 3 times every number, 3, 6, 9, 12, 15, 18. 4, 4, 8, 12, 16, 20, 24. Counting by 5s, 5, 10, 15, 20, 25, 30. And the last one is everything is times 6. 6, 12, 18, 24, 30, and 36. So there are outcomes. We should have 36 total because there were 6 numbers, right? So we should have 36 outcomes. So what is the probability that the product of 2 numbers Drake rolls is a multiple of 4? So multiples of 4 are any number that 4 will go into, right? So we know that all the 4s here are multiples of 4. And all of these are multiples of 4, right? But then we're going to have to look for the other ones that are in here. So 4 is a multiple of 4, right? 12. 12. 36. And that's it. So how many numbers did we circle? So count them up. 1, 2, 3, 4, 5. And that's 6. So it's 11, 12, 13, 14, 15. So 15 out of 36 numbers are multiples of 4. And nothing, well, we could simplify it. We could divide by 3 if we wanted to. And get 5 out of 12. Okay. Question 3 says, what is the probability that the product of 2 numbers Drake rolls is less than 13? So looking back at that table, how many numbers are less than 13? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So that would be 23 out of 36. So the table is a good way to organize your information. Okay, the next set of directions say you flip 3 coins and want to explore possibilities of certain events. So we're going to complete the tree diagram and make a list to find the sample space. And we already did this one in our example, so this is going to be easy for us. Okay, so you can roll heads or tails, and theirs is going the other direction than what we did ours. Okay, the second one from the head, you could get heads and then heads, tails. So down here, we just put heads, tails, right? Over here, you could have had a tail on your second coin. Heads, tails, heads, tails. So we already made this list on our notes, right? So let's just follow this one. Heads, 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 tails. This one's going to be heads, tails, heads. I'm going to make this bigger so I can write easier. Following this one along, right, we get heads, tails, 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 heads, heads, tail, head, tail. Over here we have tail, tail, head, just following your T diagram, tail, tail, tail. So that's our sample space. That's all of our outcomes. So how many outcomes are in your sample space? Well, we already know there are 8, because we could just take 2 times 2 times 2 to get our sample space also. List all the ways to get 3 tails. Well, there's only one way. Tails, tails, tails. Question 7 says to complete the expression to find the probability of getting 3 tails. So the number of outcomes with 3 tails, which was only 1, right? Out of the total, which is 8. So the probability of getting 3 tails when 3 coins are flipped is 1 out of 8. What's the probability of getting exactly 2 heads? So if we look back above, how many outcomes are there with 2 heads? Well, 1, 2, 3. So there are 3 ways to get exactly 2 heads, okay? You could get heads, heads, tails, heads, tails, heads, or you could get tails, heads, heads. So the number of outcomes with exactly 2 heads is 3 out of the total of 8. The next question is your essential question. There are 6 ways a given compound event can occur. What else do you need to know to find the theoretical probability of the event? You know the ways, you need to know the number of equally likely outcomes in the sample space. So you need to know the number of equally likely, outcomes in the sample space. So you don't just need to know how many times it occurred, but also how many equally likely outcomes there are in that sample space.